Okay, let's unpack this. Imagine a future where the next global conflict isn't fought on land or sea, but silently, hundreds of kilometers above us, among the stars.
Hmm.
What if the battleground is already in orbit, and the combatants are not soldiers, but satellites? What if these celestial sentinels, once symbols of peaceful science, are now actually poised for a new kind of war?
It's a pretty chilling thought, isn't it?
It really is. And that's precisely what we're diving into today, a truly fascinating and frankly a little unnerving exploration of the militarization of space.
Yeah.
We'll trace the history of our cosmic endeavors,
Hmm.
from the first tentative rockets to today's hyper-advanced orbital platforms, and ultimately try to figure out where the race for this final frontier is truly headed.
And our guide through a lot of this complex territory today comes from a really insightful conversation with Mookie Tenenbaum. He's an international observer who really pulls back the curtain on this often overlooked area.
He definitely does.
Indeed. So our mission for you today, our curious listener, is to explore Tenenbaum's compelling discussion. We want to look at how space, which, started as this realm of pure scientific wonder and national prestige.
Right, flags and footprints.
Exactly. How it's rapidly transformed into a critical domain for national security, for economic power, and maybe even the future of global conflict itself.
It's a huge shift.
It is. We'll try to connect the dots from that intense Cold War space race to the explosion of private space ventures we see today.
Like SpaceX, Blue Origin,
Yeah.
all that.
Right. And we'll even peer into the potential future of orbital warfare, helping you understand not just what is happening up there, but why it matters so deeply for life down here on Earth and, what really stands out to you in this rapidly evolving landscape.
Okay, let's get into it. Section 1.
Yeah.
The New Space Race, a future forged in conflict.
Hmm.
So Tenenbaum kicks things off with a pretty stark and immediate warning. He suggests that the next major global conflict might not play out on, land or sea, but rather in the silent vacuum of space.
Yeah, he doesn't really mince words there.
Not at all. And he points to a very specific and frankly alarming development, a Russian satellite launched this year. Apparently, it has the undeniable ability to actively move within orbit and, attack and destroy other satellites.
Right. This isn't the old style of anti-satellite weapons.
Exactly. This isn't about shooting missiles from Earth anymore. This is where it gets truly unsettling.
And the key revelation here, according to Tenenbaum, is the profound shift in strategic thinking. He highlights that for decades, since way back in 1985, nations have had weapons capable of targeting satellites from Earth.
They were ASIS missiles.
Yeah, ASATs. But these were complex, hugely expensive, requiring incredible precision to hit a relatively small target from hundreds, maybe thousands of kilometers away. Massive ground infrastructure needed, immense calculations.
Very difficult.
Very difficult. Strategic, yes, but sort of cumbersome. This new Russian concept, though, it fundamentally changes the game. It brings the battle into space itself. So instead of a missile launched from a continent far away, you potentially have a sophisticated satellite that can maneuver, maybe stalk, and then disable or destroy another satellite right there in orbit.
Wow.
This move from a standoff attack to almost close quarters engagement in orbit, it raises a really critical question Tenenbaum focuses on. What are the implications of a conflict fought literally within our vital orbital infrastructure?
It's a totally different kind of warfare.
Completely different paradigm for engagement, for escalation, for the security of everything, GPS, communications, weather forecasting, everything that relies on space.
It truly is a paradigm shift. Just imagine it. Instead of launching a missile at a satellite from the ground, maybe thousands of miles away, you send another satellite to it, like some kind of orbital assassin.
Mm-hmm.
This capability implies, an unprecedented level of stealth, control, precision, and targeting. It moves beyond just brute force ASATs to a more, surgical in-orbit approach.
Right. You could be talking about direct physical intervention, maybe even capturing or forcing an adversary's satellite to deorbit, rather than just blowing it up and creating more debris.
Which has its own problems.
Exactly. But the geopolitical fallout from any such act, it would be immense. It would mark a clear escalation of tensions into what Tenenbaum calls the next theater of war.
Okay, so to really grasp the scale of what Tenenbaum is describing here, we need to understand the main arena for this potential conflict.
Yeah.
He explains that most satellites, especially the crucial ones for comms, intelligence, navigation, they operate in what's known as low Earth orbit, or LEO.
Right, ILEO, that's the closest orbital shell.
Yeah, we're talking about the band roughly between, what, 160 and 2,000 kilometers above Earth, something like that?
Approximately, yeah.
Yeah.
And it's not just empty space up there.
No, definitely not. It's an increasingly congested orbital highway. It's home to everything from, the huge Starlink constellation doing internet stuff to critical spy satellites, weather satellites.
The International Space Station is up there too.
Right. It's where pretty much all the action happens, both for essential global services and, well, now, potentially for military engagement, too.
And if we zoom out, ILEO certainly feels incredibly congested, doesn't it? Especially when you think about the sheer number of objects zipping around at, what, 17,000 miles per hour?
It sounds terrifyingly crowded.
It does. And Tenenbaum brings up that commonly discussed hypothesis, the Kessler syndrome. You hear about this a lot.
Yeah, the chain reaction idea.
Exactly. The theory that just one collision in orbit could create enough debris, junk, to cause a chain reaction, destroying more satellites, generating even more debris, and potentially rendering entire orbital bands unusable for, well, decades, maybe even centuries.
That's the nightmare scenario, total gridlock.
It is. It's a terrifying, often cited scenario that highlights just how fragile our space infrastructure might be. However, Tenenbaum offers a surprising, sort of counterintuitive perspective that challenges this widely held fear. He urges us to think about the scale a bit more deeply.
And his analogy really puts things into perspective, doesn't it? I thought this was fascinating.
Me too.
Tenenbaum notes that while figures often cite, say, 150,000 satellites and fragments, active satellites, dead satellites, bits of rockets, you name it, maybe even double or treble that number.
Right, the numbers seem huge.
They do. But he says the sheer volume of LEO is often vastly underestimated. He compares it to the combined surface area of the Atlantic, Pacific, and Indian Oceans. All of them together.
That's a lot of space.
It's enormous. Now think about that. In our actual oceans, you'd find far, far more than 150,000 ships, boats, submarines, whatever, at any given moment. And yet, major collisions, while they certainly happen, are statistically pretty rare compared to the amount of traffic.
Okay, I see where he's going.
So Tenenbaum suggests that while the risk of collision is undeniably present, and we've definitely had close calls, he mentions the International Space Station recently getting a small hole from a tiny screw, which could have been really serious.
Yeah, those tiny things can be lethal at orbital speeds.
Exactly. But the overall probability of a catastrophic Kessler-like cascade might be, as he puts it, infinitesimal relative to the immense volume of space actually available.
So it's a crucial distinction between perceived density, like looking at dots on a 2D map, versus the actual immense 3D volumetric space. This reevaluation of LEO's density is quite profound, actually. It leads us to an important question. How do we reconcile the perceived risk of overcrowding and this, catastrophic chain reaction scenario with the actual vastness of space? Tenenbaum's comparison highlights that while space debris is absolutely an undeniable and growing concern, nobody's dismissing that.
No, it's a real problem.
It is. But the immediate threat of a complete Kessler-like cascade might be perhaps overstated when you properly grasp the sheer scale of LEO. And this perspective doesn't dismiss the problem, but it maybe shifts our focus a bit. It suggests that while managing traffic and mitigating debris are crucial ongoing challenges, the more terrifying prospect might actually be the increased likelihood of intentional hostile actions within this incredibly large yet strategically vital orbital band rather than purely accidental collisions.
So the killer satellite threat becomes even more pertinent if accidental collisions are less likely than we thought.
Potentially, yes. It forces us to think about a different kind of traffic control, altogether one focused on preventing deliberate attacks, not just accidental bumps.
Right. Okay, that sets the stage for the current tension. But to really appreciate this new space race, maybe we should revisit the original one, Section 2. Echoes of the Past. The original space race and its legacies.
Good idea. History definitely informs the present here.
So Tenenbaum takes us back, reminding us of that huge shock, October 4th, 1957, the unexpected launch of Sputnik by the Soviet Union.
A pivotal moment absolutely galvanized the U.S.
Totally ignited the Cold War space race. And Tenenbaum highlights a crucial historical detail that maybe not everyone knows. While the U.S. had brought over several brilliant German rocket scientists, like Wernher von Braun, from the V-2 rocket program after World War II.
Operation Paperclip, right?
Exactly. The Russians, through, well, various means, managed to get their hands on the actual plans for the V-2 rocket.
Ah, the blueprints.
Yeah. And Tenenbaum suggests this crucial advantage in foundational rocketry ultimately allowed them to launch the first satellite, Sputnik, catching the U.S. completely off guard and creating this palpable sense of alarm worldwide.
It was undeniably a critical turning point, not just scientifically, but geopolitically. And Tenenbaum reminds us the Russians didn't just stop there. They didn't rest on their laurels after Sputnik 1.
No, they kept going.
They cemented their early, significant lead with a rapid series of achievements. Just a month later, Sputnik 2 carrying the dog Laika, the first living creature in orbit. A huge feat, scientifically and symbolically.
Poor Laika.
Indeed. And then, most famously, April 1961, Yuri Gagarin, the first human in space, completing a full orbit. These accomplishments underscored an early, significant, and undeniable lead for the Soviet Union. It wasn't just about tech, it was a psychological and propaganda war, too.
Winning hearts and minds.
Absolutely. The symbolic victories were immense back then.
And then, of course, came the monumental challenge, the race to the moon. Kennedy's famous speech, the Apollo program, which the U.S. eventually won with Apollo 11 in July '69, Neil Armstrong, Buzz Aldrin. An incredible moment.
Unforgettable. Watched by the whole world.
But, as Tenenbaum points out, once that huge symbolic victory was achieved planting the flag, things started to shift. The focus began moving away from purely manned missions driven by national pride and towards another, perhaps even more strategic purpose for satellites.
Right. The era of grand, symbolic human achievements started to, well, give way to more pragmatic military and intelligence applications of space.
And Tenenbaum explains that early Russian satellites, specifically the Cosmos series, which started launching in the early 1960s, quickly evolved. They went beyond just scientific experiments and were repurposed into, well, spy satellites.
Orbital eyes.
Exactly. And he notes the inherent advantage these platforms had. Being up so high makes them incredibly difficult to interfere with or take down, short of a direct destructive strike, which, as Tenenbaum emphasizes, would be seen as an act of war, causing a massive international incident.
A huge red line.
A huge red line. These satellites were largely invulnerable. Destroying another nation's satellite carries severe diplomatic, economic, military repercussions. Few would cross that lightly.
And what's truly fascinating here, as Tenenbaum details, is the rapid evolution of their capabilities. He points out the initial challenge. The higher your orbit, generally, the lower the photographic definition, especially with 1960s tech.
Right. Trying to see details from hundreds of kilometers up must have been tough.
A monumental challenge. Yet technology improved astonishingly fast. Optics got better, film became more sensitive, and later, digital imaging arrived.
Constant innovation.
Relentless pursuit of better imagery, broader intelligence. This led to a proliferation of secret spy satellites. Soon, it wasn't just the US and Russia. Tenenbaum lists them. China, Europe, India, Israel, Iran, even North Korea eventually launched their own orbital eyes.
Everyone wanted in on the game.
Everyone sought that informational edge, monitoring military movements, economic activity, strategic installations of rivals, all from the seemingly unchallenged vantage point of space. It became a global intelligence free-for-all, high above us.
So, in essence, the first real battle for space, beyond just prestige, was an intelligence war, wasn't it?
Pretty much.
It was about controlling information, seeing what others were doing without them knowing, a silent strategic conflict thought in orbit, shaping decisions down here. But as Tenenbaum discusses, the reasons for being in space didn't stop there. They quickly evolved again, moving from observation towards, well, exploitation.
Right.
Resources, commerce, the next phase.
Which brings us to Section 3. Beyond flags and footprints, from exploration to exploitation. Now, this is a question I think many of us have wondered about. Why did we start sending astronauts to the moon after Apollo 17 in 1972, especially with today's technology being so much better?
It's a common question, and Tenenbaum offers some very direct, pragmatic reasons. He kind of cuts through the romanticism.
Okay, what are they?
Well, Tenenbaum explains a few key factors. First, simply put, NASA's budget got slashed pretty significantly after the Apollo program achieved its main goal, winning the moon race against the Soviets. The intense political will and massive funding just weren't sustained.
The political impetus faded.
Exactly. Second, and maybe more fundamentally, there was a strategic shift. It became clear that robotic exploration was often more logical, safer, and vastly cheaper than continuing with costly and inherently risky human missions.
Robots don't need life support. Precisely. Tenenbaum argues, pretty forcefully, that sending people to do tasks that sophisticated robots can achieve, especially with today's AI and automation, makes little practical sense from a cost-benefit perspective. He sets the incredible example of the Voyager probes. Launched in 1977, he corrects the common 72 misconception Voyager 1 and 2. They gave us our first detailed look at Jupiter, Saturn, Uranus, Neptune. Just incredible science.
Still going, aren't they?
Still going. Decades later, they're beyond our solar system, still sending back data, powered by these robust atomic reactors. They perfectly illustrate how advanced robotic systems can achieve far more, for far longer, at significantly less risk and cost than human crews.
And Tenenbaum also makes a crucial point about the danger of those atomic reactors, right? Like the plutonium powering them.
Yeah, he touches on that. While incredibly efficient for deep space, if one of those reactors were ever to fall back to Earth during a launch or some other mishap, it would pose a serious environmental hazard.
Right. He also mentions the space shuttle program. Looked amazing, very grand.
Iconic, yeah.
But ultimately, Tenenbaum says, it just wasn't economically viable. The cost per launch, combined with the inherent risks, sadly demonstrated by the Challenger and Columbia tragedies, proved unsustainable. It was eventually retired.
And that experience further solidified the argument for cheaper, safer, more efficient robotic missions. No need for life support, food, water, psychological support for long isolation.
All the complexities of keeping humans alive in space.
Right. So this confluence of economic reality, inherent danger, and rapidly advancing robotic capabilities, it drastically altered the trajectory of space exploration. It moved us away from the symbolic flag-planting stuff of the Cold War.
Towards something else.
Towards a new era, paved the way for it anyway. One driven increasingly by automation, efficiency, and crucially, as Tenenbaum emphasizes, burgeoning commercial and military interests. The romantic ideal faded, replaced by calculating pragmatism.
Which sets the stage perfectly for the arrival of private enterprise. And that new era, focused on commercial exploitation, as Tenenbaum vividly describes, truly arrived with Elon Musk and SpaceX.
Yes.
Before Musk, space was almost exclusively the domain of governments. NASA, Roscosmos, ESA. Launch costs were astronomical, timelines stretched for years, decades sometimes.
Very bureaucratic, very expensive.
Extremely. SpaceX decided to radically disrupt that model, turning space access into a business. And, well, it's been incredibly successful, fundamentally reshaped the whole industry.
What's truly astonishing here is the sheer scale of private enterprise in space that Tenenbaum emphasizes. SpaceX, for instance, he mentions they've launched something like 40,000 Starlink satellites.
40,000. It's an unbelievable number.
It speaks volumes about the commercial viability and just the aggressive deployment strategy of these private ventures. And Tenenbaum points out Musk's huge innovation, recovering and reusing those expensive rocket parts, the first-stage boosters.
Landing them back on Earth or on drone ships.
Exactly. Stuff that used to be just ditched in the ocean after every launch. This reusability, which many in the old guard thought was impossible or impractical, fundamentally changed the economics, made space access far cheaper, more frequent, more sustainable.
A total game changer.
Absolutely. And that commercial success, of course, spurred others. Jeff Bezos, with Blue Origin, pouring capital into the private space sector, created a real modern-day private space race.
And this commercial shift isn't just about launching satellites cheaper, is it? Tenenbaum mentions something about asteroid mining.
Yeah, he brings it up. He mentions a specific law passed in Luxembourg, of all places, allowing companies to actually form with the explicit purpose of mining asteroids. Seriously. The focus is specifically on those mineral-rich asteroids out in the belt between Mars and Jupiter. This really underscores the dramatic pivot Tenenbaum talks about.
From prestige to profit.
Exactly. The motivation moved from national prestige and scientific discovery to tangible profits and resource acquisition. It's about resource independence, maybe enabling future deep space construction or fueling. It's like a literal space gold rush. And the legal frameworks are already being put in place.
Wow. Okay, so with all these shifting motivations, flags, science, profit, where do we actually stand now with those big dreams? Returning to the moon, colonizing Mars?
Well, Tenenbaum offers a distinctly skeptical view on some of that, particularly regarding near-term human settlement. He mentions China's stated goal of a lunar base by 2030.
Yeah, you hear about that.
And he pretty much calls such claims fables. He just reiterates his core argument. Sending humans to the moon for sustained periods makes little pragmatic sense right now, not when highly advanced robots, powered by AI, can do the work more efficiently, with fewer logistical nightmares, and without needing air, food, water.
All that expensive life support.
Right. He's very direct about the current impracticality of human lunar colonization for any economically viable purpose.
Okay, but what about resources on the moon? Water, ice, minerals?
He acknowledges that water ice has been confirmed at the lunar poles, which definitely makes a future base more viable. Water is crucial for drinking, for oxygen, for rocket fuel.
Right, you can split it into hydrogen and oxygen.
Exactly. But the claims about abundant, easily accessible, commercially valuable minerals, Tenenbaum views those as still highly speculative.
Why is that?
He posits that the moon likely has pretty similar elements to Earth, because the leading theory is that the moon is a fragment of Earth ripped away in a giant impact billions of years ago. So finding unique, super valuable, easily extractable minerals may be unlikely, he suggests.
But he does mention one advantage of the moon.
Yes, he does, the moon's lower gravity. That makes it a potentially far more fuel-efficient place to launch rockets from if you're heading deeper into space, say to Mars or the asteroid belt.
Like a refueling station or a launch pad?
Potentially a stepping stone, but that still requires monumental upfront investment in infrastructure that just isn't there yet.
And here's that really thought-provoking point Tenenbaum makes, the one that kind of grounds us back on Earth.
The ocean floor comparison.
Yeah. He said, before we even seriously think about lunar mining or chasing asteroids, maybe we should properly explore our own ocean floor. It remains largely uncharted, probably holds vast, undiscovered resources.
Good point. We know more about the surface of Mars than our own deep oceans.
Exactly. Why spend billions on speculative off-planet mining, he asks, when we haven't fully explored what's right beneath our waves? It really does challenge our priorities, doesn't it?
It certainly does. And on Mars, what's Tenenbaum's take there?
He notes that current missions, Perseverance, Ingenuity, are primarily scientific. They're looking for signs of past or present microbial life, studying geology, atmosphere.
Pure science.
Pure science. No immediate exploitation interest in terms of resources. He even recounts a personal anecdote. Apparently, Elon Musk offered him a spot on a Mars colonization mission way back in, 2005 or 2006.
Oh, really?
Yeah. And Tenenbaum, with his typical pragmatism, viewed it then, and still seems to view it now, as more of a fantasy than a practical economic project, at least for anyone alive today. The challenges, radiation, distance, cost, logistics are just colossal.
So the bottom line for Tenenbaum, it seems, is that external space, the moon, Mars, asteroids, is far less important, certainly in the near to medium term,
Then what?
than the orbital space around Earth itself. He argues the real battleground, the true arena for future conflict and economic power, is much closer to home, right there in low Earth orbit.
Which brings us right back to where we started. Section 4. The new arena of war orbital battlegrounds and AI supremacy.
The sharp end of the stick.
This brings us squarely back to Tenenbaum's opening point. His firm belief that we are genuinely on the cusp of seeing wars fought directly between satellites in orbit. This isn't sci-fi anymore. It's an emerging reality nations are actively preparing for.
And he points to concrete evidence for this preparation.
He does. He highlights the establishment of the U.S. Space Force under President Trump, making it a distinct branch of the military that was a huge signal, wasn't it?
Absolutely. It formally acknowledged space as a legitimate warfighting domain, needing its own specialized people, strategies, technologies.
Cemented the idea.
And placing this in a wider context, establishing forces like the Space Force highlights this profound shift in military strategy, extending traditional battlefields into the vacuum, which, Tenenbaum points out, immediately begs a critical question.
Which is?
How do you govern a domain like that? No clear borders, no established international law specific to orbital conflict, not really any universally agreed upon rules of engagement.
Right, it's kind of the Wild West up there.
In some ways, yeah. Tenenbaum explains there's no global authority, no space traffic control for military or spy satellites. The U.S. proposed the Artemis Accords, trying to create a framework for rules and coordination. But it's largely voluntary, more focused on peaceful exploration, and crucially, not signed by key players like China and Russia and spy satellites. As Tenenbaum notes, they typically don't coordinate their movements, they operate secretly.
Makes agreements hard to enforce, doesn't it?
Exactly. This lack of robust governance creates a dangerous vacuum where hostile actions could escalate rapidly, unpredictably.
And he points out that this orbital band, this franja, as he calls it, well, it's geographically vast. It's also incredibly busy.
Yeah, the numbers he throws out are pretty staggering.
He estimates anywhere between 40,000 and maybe even 120,000 objects Active satellites, dead ones, debris with maybe 60,000 tracks from Earth, all flying through this gigantic area at insane
So,
speeds.
so while accidental collisions might still be statistically rare, as per his ocean analogy,
Right.
the risk of intentional engagement, one satellite actively targeting or interfering with another, that risk is growing exponentially with capabilities like that Russian killer satellite. Its mere presence changes the risk calculation for everyone.
Definitely raises the stakes.
Tenenbaum also discusses the development of what are called soft kill options, specifically laser systems designed to blind satellites.
Blinding them, how does that work?
Well, think of focused energy weapons. Lasers powerful enough to overwhelm or maybe even burn out sensitive optical sensors, cameras, infrared detectors, communication antenna on an adversary's satellite.
So disabling it without blowing it up.
Exactly. Rendering it useless without creating a huge debris field. The challenge is precision targeting over vast distances, keeping the beam locked onto a fast-moving target. Tenenbaum cautions this tech is still in its early stages, not fully mature for widespread use yet.
But the potential's there.
Oh, yeah. Prototypes have shown success. It suggests a future where these soft kill options, jamming comms, dazzling sensors might be used before resorting to destructive kinetic attacks, offers a kind of graduated response ladder in orbit.
From interference to disablement to destruction.
Something like that. Because kinetic destruction creates debris and huge geopolitical fallout.
And speaking of debris, Tenenbaum highlights that with so many objects up there, visible and invisible, tracking them all is just an absolute nightmare.
Yeah, countless untracked pieces.
Yeah.
Tiny fragments from old rockets, defunct satellites, maybe previous collisions. Too small to monitor easily, but big enough to cause catastrophic damage if they hit something important.
A real hazard. And he mentions China is launching its own huge constellations now too, right? Competing with Starlink.
Yep. Thousands more satellites planned, adding to this already overwhelming orbital clutter. The space pollution problem is demonstrably getting worse, not better, despite some mitigation efforts.
Is there an environmental impact too? Besides just clutter.
Tenenbaum brings that up, referencing scientists complaining about light pollution from these satellite mega-constellations.
Light pollution from satellites.
Yeah, thousands of these things, like Starlink, reflecting sunlight, creating bright streaks across the night sky. They interfere with ground-based telescopes, make deep space observation harder.
Wow, I hadn't thought of that.
It raises a really important question Tenenbaum touches on. What's the long-term impact of this exponential growth on our ability to actually study the universe? How do we balance these powerful commercial and military interests with the vital pursuit of scientific knowledge?
Another conflict right there. Use versus observation.
Pretty much.
Tenenbaum also touches on the satellites themselves. Huge range in size. Right?
Oh, yeah. From tiny CubeSats, maybe just a few kilos, often for university research or tech demos.
Little boxes.
Little boxes, yeah.
Yeah.
All the way up to multi-ton giants for communication or reconnaissance. And obviously, as Tenenbaum reminds us, heavier satellites cost way more launch. Takes more fuel to escape gravity.
Makes sense. And he points out private companies often operate with less oversight.
Potentially, yeah. Less transparency than government agencies sometimes regarding launch practices, debris mitigation plans, could exacerbate the problem without the same level of accountability.
Interesting. And for people wondering how these things even get up there, Tenenbaum gives a quick rundown of launch sites.
Yeah, a quick global tour. Cape Canaveral in Florida for the U.S., obviously iconic. Kourou in French Guiana for Europe, strategically close to the equator in South America.
Why the equator?
Tenenbaum explains it lets rockets take advantage of Earth's rotational speed, gives them a boost, uses less fuel to reach orbit. Russia primarily uses Baikonur Cosmodrome in Kazakhstan, also chosen for its favorable latitude, and China launches from sites in southern China.
Okay. He mentions visiting Cape Canaveral himself.
Yeah, he shares a quick personal anecdote. Went to see a SpaceX launch, called it a very moving experience, witnessing that raw power and ambition firsthand.
I can imagine. So back to the drivers. Tenenbaum argues private capital brought speed, innovation, and new objectives. What about space tourism? Is that a big factor?
He touches on it, but seems pretty dismissive for now. Says it's still very niche, largely aspirational. Mentions talk of space hotels.
Yeah, you hear about those concepts.
But says we're very far from that. It's certainly not the primary driver of this new space economy, in his view. The real forces, Tenenbaum insists, are communications and espionage. Those are the profit centers and strategic imperatives making these massive investments worthwhile.
Comms and spying.
Pretty much. And Starlink is the perfect example of this duality, this blend of commercial and military interest. Tenenbaum emphasizes it's become so critical to U.S. national security, ubiquitous comms for military intel, even civilian ops in contested zones.
Like in Ukraine.
Exactly. That the U.S. government, he argues, simply cannot afford to cut relations with SpaceX. This creates a really complex, novel situation.
How so?
It raises a fascinating question. What does it mean when a vital national security asset, maybe the backbone of critical operations, is controlled by a private company? One with no public shares, whose internal workings and profits aren't transparently known.
A private company holds huge geopolitical leverage.
Precisely. A complex web of dependence between private power and national interest.
And Tenenbaum makes another key point about Starlink's broader impact, right? Beyond the military stuff.
Yeah, the potential to bypass state censorship. It doesn't just provide internet, it can provide it anywhere, potentially circumventing government firewalls or restrictions.
A tool for freedom of information.
Potentially, yeah. Imagine getting uncensored global info in a heavily restricted region via a Starlink dish. Powerful idea, though Tenenbaum quickly adds a caution.
What's that?
Don't assume Starlink guarantees anonymity if you're doing something illegal. Governments will always find ways to monitor and track. Anonymity is never absolute, even with new tech.
Good point. Okay, now this next part. This seems crucial to Tenenbaum's whole argument about future conflict. AI.
Yes. This is where he believes the game truly, fundamentally changes. He states it unequivocally. Artificial intelligence is fundamental for space warfare. Not just helpful, but essential.
An absolute prerequisite.
Absolutely. And here's the kicker. The point Tenenbaum says creates a decisive imbalance. China, he argues, demonstrably lacks advanced AI capabilities and, critically, the cutting-edge microchips needed to develop and deploy it effectively.
They're behind on the hardware.
Significantly, yes. And Russia, he points out, is even further behind. It's not just about clever software. It's about the underlying hardware infrastructure, the specialized chips required to run truly sophisticated real-time AI in demanding environments like space.
And the difference this makes is...
Tenenbaum predicts it will be a brutal difference. He argues U.S. supremacy in AI will widen dramatically, creating a potentially insurmountable power gap between the U.S. and China-Russia in space.
Wow. Not just faster reaction.
It's way beyond that. It's a complete paradigm shift in strategic planning, real-time decision-making, autonomous execution. Imagine AI coordinating defensive maneuvers faster than any human could track, or predicting vulnerabilities in an enemy satellite constellation. If a satellite needs to react instantly to a threat, or execute a complex maneuver at orbital speeds, Tenenbaum stresses a human operator is just too slow because of signal latency. The AI needs to be on board the satellite.
And the nation with the best AI wins.
Holds an undeniable, potentially decisive advantage. That's Tenenbaum's core argument here.
He mentions an interesting side idea about data centers in space from Eric Schmidt and Jeff Bezos.
Yeah, the concept of using the cold vacuum for natural cooling and constant solar energy for power. Sounds good on paper, right?
Seems logical.
But Tenenbaum quickly dismisses it for immediate real-time internet use. Why? Latency, the inescapable time delay for signals traveling from Earth to orbit and back.
Too slow for Zoom calls or online gaming.
Exactly. Makes space data centers only viable for things like data backup, archival, maybe specific scientific computations that aren't time-sensitive. He sees it as illustrating a common misunderstanding of space's practical challenges for certain commercial ideas.
Okay, so this widening AI gap, that's unsettling.
Deeply unsettling. And it raises another important question Tenenbaum poses. What happens when nations feel they're being left behind? When they see this technological chasm in AI widening, might they take drastic measures to try and level the playing field?
Like what?
Tenenbaum suggests we might see more attempts to jam or block rival satellites, interference with communications, navigation signals, actions likely kept covert, blurring the lines of what constitutes an act of war in space.
Gray zone conflict.
Exactly. These activities, below the threshold of open kinetic conflict, could slowly escalate, chipping away at stability, making the domain even more unpredictable.
And the ultimate consequence, if things escalate further, Tenenbaum paints a stark picture.
He does. War between machines. He envisions drones fighting drones on Earth and satellites fighting satellites in orbit.
Because humans are too slow.
Precisely. He emphasizes humans simply cannot react fast enough in space due to that inherent signal latency, maybe half a second round trip minimum, far too long for effective control at orbital velocities.
So you need AI on board.
Sophisticated AI, embedded directly within the satellite, becomes absolutely necessary for both defense and attack. It fundamentally alters warfare into a robotic chess game played at hypersonic speeds.
Chilling stuff.
Mm?
Which brings us to the human element or lack thereof. Section 5. The human element and the geopolitical chessboard.
Right. Where do people fit in this picture?
So with all this focus on satellites, AI, orbital battles, what about humans in space? Are we still relevant up there? Tenenbaum is pretty clear, maybe even blunt.
Yeah, his assessment is quite stark.
He says there are very few people in space right now, maybe 2 or 3 at any given time, primarily on the ISS or similar stations. And he believes their presence, quite directly, is largely useless in terms of practical value compared to what robots can do now.
Useless is a strong word.
It is, but he backs it up by highlighting the severe physiological toll that long-duration space travel takes on the human body.
Yeah, the health effects are well documented.
Significant bone demineralization, muscle wasting, cardiovascular changes, radiation exposure. The list goes on. He recounts that fabulous experiment with the identical twin astronauts, Mark and Scott Kelly.
The NASA twins study.
Right. Scott spent a year in space, Mark stayed on Earth. The data clearly showed how much worse Scott fared physiologically. It really hammered home the detrimental effects.
And creating artificial gravity, like in sci-fi movies.
Tenenbaum says it's theoretically possible, maybe through rotation, but remains a very difficult, complex engineering challenge to implement effectively on a large scale for long missions. So it raises the question Tenenbaum implicitly asks, are we past the point where human presence in space is truly valuable, beyond maybe symbolism, some niche science, or very short-term tourism?
The costs and challenges are immense, and the practical returns, he argues, are diminishing compared to robotics.
And Tenenbaum explicitly states that the old Cold War era, where symbols were worth more, planting the flag, being the first human,
That era is over.
that era is definitively over, in his view. In this new Cold War, this new geopolitical struggle, which he sees as far more pragmatic, its actions and demonstrable technological superiority, especially with AI and orbital capabilities that truly matter. Pragmatism and capability trump symbolism now.
Makes sense in this context.
So what about smaller countries? Can they still realistically aspire to be significant space players, launching their own advanced satellites, for instance?
Tenenbaum is pretty direct and skeptical here, too. He uses Bolivia's stated desire for its own satellite as a sort of case study.
Okay.
He questions the immense cost acquiring, launching, maintaining such a complex piece of hardware. And critically, what's the actual strategic or economic benefit of claiming sovereignty over what he calls a piece of metal orbiting Earth?
Especially compared to other options.
Exactly. He argues that sophisticated drones, unmanned aerial vehicles, are increasingly affordable and can often perform similar espionage or surveillance tasks more effectively, more discreetly, and without the astronomical overhead of a national satellite program.
So for many countries, it might not be the best investment.
That seems to be his take. He does acknowledge that some countries, like Israel, have clear, compelling strategic reasons for their own advanced spy satellites. Given their regional conflicts, they have an urgent, constant need for real-time intelligence on neighbors and adversaries.
A specific, unavoidable need.
Right. But for most other small or developing nations, Tenenbaum doesn't see a significant future for them operating truly independent, cutting-edge spy satellite systems. He even notes that Europe's collective space focus is often on things like climate observation, and even then, they frequently rely on or complement data provided by the U.S.
The barrier to entry is just too high. Technology, cost.
Immensely high. Smaller players would likely be outmatched and outspent, struggling to keep pace with the rapid tech advancements and massive investments of the major powers like the U.S. and China.
So ultimately, Tenenbaum's conclusion is
that while many countries will undoubtedly continue to spend money on space for national pride, perceived strategic needs, maybe just for show, it often won't make practical or economic sense for smaller nations to pursue truly independent advanced orbital capabilities.
okay.
And he reiterates that if a war does occur in space, it would almost certainly be a highly specialized struggle between the major powers, focused on, as he puts it, obscuring or disrupting each other's vital satellite infrastructure, blinding, jamming, maybe kinetic attacks on key assets, not a widespread multinational free-for-all.
It's a high-stakes, exclusive game, played primarily by a few tech giants.
That's the picture Tenenbaum paints.
Well, this deep dive into Mookie Tenenbaum's insights, it truly has shown us how the silent frontier of space is, well, anything but silent or inactive.
Far from it.
From that intense historical race for national prestige to today's relentless scramble for economic and military dominance up there, it's abundantly clear. The future of conflict, global communication, even our basic understanding of the universe, it really hinges on what happens hundreds of kilometers above our heads.
Mm-hmm.
The dramatic shift to private enterprise, the undeniable growing importance of AI Tenenbaum highlighted, and the very real threat of orbital warfare.
Mm.
It paints a complex, utterly fascinating, and, yeah, at times, deeply unsettling picture of our future.
Indeed. We've really seen through Tenenbaum's analysis how the very definition of battlefield is evolving, pushing way beyond terrestrial limits into a domain where human intuition is just too slow and autonomous systems are rapidly becoming paramount.
Right.
And this raises, I think, an important final question for you, our listener, to really consider. If the next great power struggle is fought and potentially won by autonomous machines in orbit, silently influencing everything down here on Earth, from our smartphones to our national security, how will we as a society adapt to and oversee a domain of warfare that is largely invisible, conducted at speeds beyond human comprehension and increasingly beyond direct human intervention? What does truly informed citizenship even mean in a world where our most critical infrastructure, our very security, could be threatened by a killer satellite or a digital attack launched silently in the vacuum of space?
Wow. Something to really mull over, isn't it? The implications are just vast. Thank you for joining us on this deep dive. Until next time, keep looking up and keep thinking critically.